Hello everybody, I'm Kyle from Circuits.io, and today I will show you how to easily create an Arduino shield using the Arduino shield template that I've recently created. The shield we're gonna build is based on the Accelero Gyro module, which was originally created on Circuits.io by Tim Wageman. I forked his design and rerouted some of the nets so that the module terminals are more easily accessible. The first thing we need to do in order to create the Arduino shield is fork the Arduino shield template. The only thing this template contains are the connectors that are needed to connect the shield to the Arduino, and these connectors are already placed in the right spots on the board, so that makes it a little bit easier to create a shield for the Arduino. Okay, the next thing we need to do is to import the Gyro module into our design, and we do this by using the component picker, and we search for the Gyro module, and here it is. We select it and we drag and drop it into our circuit. This is a 3.3 volt module, so we need to hook it up to the 3.3 volt power of the Arduino, and of course also the ground. On the other hand, this module has an I2C interface, so we need to hook it up to the I2C of the Arduino. Okay, but we have a slight problem here. Since the module is a 3.3 volt module and the Arduino works at 5 volts, we'll need some level conversion circuit here. I found a nice conversion circuit on Electrical Engineering Stack Exchange, which converts a 3.3 volt I2C interface to a 5 volt I2C interface, and it uses two N-channel enhancement mode MOSFETs and some pull-up resistors for the I2C. We will design this conversion circuit as a new module so that other people can make use of this module later on. So let's create a new module. Okay, the first thing we need in order to create our conversion circuit is our enhancement mode MOSFET, and we will use the BSN20. As you can see, we're now integrated with Octopart, so anything you search for, you will get a result. There's literally millions of components in the Octopart database, and here we have our component, the Philips BSN20. As you can see, it's not yet in our database, so you get a create button, which brings you to the component creation wizard. The wizard has a link to the datasheet, so let's download it and take a look at it. So here we have it, with the BSN20 N-channel enhancement mode field effect transistor. Let's scroll down, and we see that it's packaged in a SOT23 package, and the pin out is gate, source, drain for the first, second and the third pin. Okay, let's go back to the wizard and choose the footprint. So it's a SOT23 with 3 pins. Let's choose a symbol. As the base name, we will choose Q because it's a transistor. We will not use the auto-generated symbol, but we will pick one from our symbol library. And in this case, it's a transistor, an NMOS transistor. Okay, this is our symbol. In the third step, we do the mapping. So it was gate for the first pin, source for the second pin, and drain for the third pin. Let's check that. So gate, source, drain. Okay, that's correct. So now we can push the save button, and this component is now in our database, so it can be used by anybody. Okay, let's now build this circuit. Next we need to add module terminals. These module terminals tell us how to connect this module when we import it into another circuit. So we need a 3.3 volt module terminal. We need serial data at the 3.3 volt side, and so on. That's it, let's call this module the I2C level converter module and save it. Okay, now that we finished our I2C level converter, we have to mark it as done, otherwise it cannot be imported into other circuits. And we can now go back to our shield circuit and finish it. In order to import the I2C module, we choose the component picker, search for I2C, and we get our module, we select it and import it into our circuit where we want it and connect it up. Okay, and that's it, we made a schematic of our Arduino shield. Okay, the only thing we need to do now is to lay out our shield. Let's find a good place for the modules. Let's turn this module around using the R key and find a nice spot for it. This looks good. Let's take the gyro module and put it next to it. Okay, this looks good. Okay, now let's hook up the modules. And we're done, we've created our Arduino shield with the Acceleroid Gyro module on it. Let's save it. Okay, our Gyro shield is saved. The only thing left to do now is to choose a license. Let's choose a CERN Open Hardware license and mark our design as done. Okay, next we can either download the Gerber files, or in the near future you will be able to order the board from our site. And that's it. Thank you for listening to this tutorial, and I hope to see you next time. Bye!